Digital Physics 1, first video is about signals. Now, a signal is just information going from one place to another. There's hundreds of different types of signal. If you talk to somebody, that's a signal. There's radio, satellite television, Morse code, Bluetooth, Wi-Fi. You can categorize signals into analog or digital. So an analog signal may contain lots of different frequencies and amplitudes. A digital signal is only one frequency and one amplitude. Learn them definitions. For example, this is the waveform for an analog signal. And looking at it, you can see that there's a couple of different amplitudes, a couple of different frequencies going on in there. It might be an electrical signal, it might be voltage against time. It may have been produced by a microphone. Now, a digital signal is made up of binary digits, which is we call them bits of information, binary digits, and each bit is either a 1 or a 0. Now, a typical way of doing that with a voltage is if the voltage is going down, then that's a 0, and if the voltage is going up, then that's a 1. And so as the voltage goes up and down, you get lots of noughts and ones. And that is a binary signal, a digital signal. Now, what are the advantages of digital signals? Well, it seems to me over the last 10-20 years, just about everything has gone digital, from radio and television to all types of music. Now, why? Well, the advantages are both types of signal may pick up noise, but it's much easier to recognize noise on the digital signal, and therefore it's much easier to get rid of it, to filter it out. If you look, there's a digital signal, it's picked up a little bit of noise, and I'm sure you can recognize the noise looking at that. The medium carrying the signal may contain much more useful information. A digital signal can carry much more information than an analog one. If you think about the old analog television, you could only have 6 or 7 channels at the most. With digital television, you can have hundreds of channels, thanks to a very clever thing called multiplexing. Computer memory and processing elements are digital. A memory chip, for example, is just billions of tiny switches. I talk about how the very first computers, the memory elements were little magnets, which were either magnetized north or south. From there we went to valves, which were very large and hot, inefficient things. Then to transistors, and now we're on integrated circuits. And these things can have millions and millions of tiny little electronic switches, which are either 1 or 0. Digital media can be copied without loss of quality. It can be encrypted for security if it's your bank details. And it can be processed in many other ways, which I'll talk about in another video. Here are some key terms. A bit is a binary digit, and we usually represent it with either a 1 or a 0. 1 byte is 8 bits. A kilobyte is 1,000 bytes. If you do computing, you might know it's actually 1,024, but for A-level physics, it's 1,000. A kilobyte is 1,000 bytes. A megabyte is 10 to the 6 bytes, a million, and a gigabyte is 10 to the 9, a billion bytes is a gigabyte. Here are some questions for you to have a go at. If you pause the video, I'll show the answer in 5 seconds. 3, 2, 1. And there's the answers.